Lubrication is essential for any kind of machinery on board ships. Lubrication of main engine is responsible for lubricating and cooling the internal parts, which are acting relative to each other, creating friction and heat, resulting in overheating of parts. Lubrication not only provides cooling but also assists in the removal of any debris or impurities. The main engine has three separate lubricating oil systems: main lubricating oil system, cylinder oil system, and turbocharger lubricating oil system. The main or crankcase lubricating system is supplied by one of two pumps, one of which will be operating and the other is on standby, set for automatic cut-in should there be a lubricating oil pressure reduction or primary pump failure. The lube oil for the lubrication purpose is taken from the storage tank, which goes directly to the sump. The supply is controlled by valves fitted in the line. The main lube oil pumps take their suction from main engine sump tank via an inlet filter and discharge oil via the main lube oil cooler, which takes away the heat. The plate type or shell and tube type lube oil cooler is cooled from the low temperature central cooling freshwater system. An automatic back flushing filter unit with a magnetic core helps to remove any metal debris. The supply pressure in the main lubrication system depends on the design and requirement and is generally around 4.5 bar. Lube oil supply to the cooler is via a three-way valve which enables some oil to bypass the cooler. This helps the three-way valve to maintain a temperature of around 45 degrees centigrade at the lubricating oil inlet to the engine. The main lube oil system supplies oil to the main bearings, camshaft and camshaft drive. A branch of lube oil goes to the crosshead. In man engines, the lube oil line is connected to inlet in the crosshead using a telescopic pipe. It moves up and down along with the crosshead and oil is supplied to it from the top. In Wärtsilä engines, an articulated or swinging arm is attached to the crosshead which supplies the inlet oil. Once the oil reaches the engine inlet, it does three functions. Some oil travels up into the piston rod to cool the piston and then comes down. Some oil lubricates the crosshead bearing and the shoe guides. The remaining oil passes through a hole drilled in the connecting rod to the bottom end bearing. A branch of lube oil is also led to the hydraulic power supply unit for actuation of exhaust valves, to the thrust bearing, to the moment compensator and the torsional vibration damper. Main engine lube oil purifier takes suction from main engine lube oil sump and purifies the oil. Its feed temperature is maintained around 90 degrees Celsius to allow efficient separation. The engine drains are connected to the dirty oil tank from which the lube oil purifiers also take the suction, and the purified oil is then transferred to the clean oil tank. The oil from the clean oil tank can be reused by transferring it to the engine sump using a transfer pump. The main engine lubrication system also has a subsystem which depends upon the main engine type, if it is camshaft type or if it is camless. In camless engines, a branch from the lube oil inlet to the main engine is provided to the hydraulic power supply unit or the HPS. The function of HPS is to control the fuel injection and exhaust valve actuators hydraulically and also drives the cylinder lubrication unit. In the main engine with camshaft, lubrication system feeds to the camshaft roller guides and bearings which actuates the exhaust valve and fuel pump. In the crosshead bearing, the load is very high and the motion is not continuous as the bearing oscillation is fairly short. The lube oil is supplied on the bottom portion of the bearing, which is in contact of the rod. In crosshead bearing, hydrodynamic lubrication cannot be achieved. Under such conditions, hydrostatic lubrication offers the best advantage. In some engines, the oil to the crosshead bearing is supplied at around 12 bar by a second set of booster pumps. The part of oil from the crosshead goes up into the piston and another branch goes down to the bottom end bearing via bores in the connecting rod. The piston of the engine is lubricated internally using the oil supply from the piston rod. The rod is hollow and has a pipe running up its center which takes the oil in, and there are two pipes running on the outer part of the rod which takes the oil out of the piston. The oil is supplied from the center bore, and as the piston moves up and down, the lube oil splashes inside and provides the lubrication effect, also known as cocktail shaker effect. The oil is then taken out from the outer bores in the piston rod. In some piston design, a nozzle plate and nozzle is provided inside the piston. The oil is sprayed using the nozzles into the underside of the crown, providing better cooling. There is a separate branch which goes to the main bearing of the engine. The main bearing experiences hydrodynamic lubrication which forms an oil wedge. When the crankshaft rotates, the film between the journal and the bearing starts taking up the load, and as the speed increases and pressure build up, the oil film supports the load. The turbocharger bearing lubricating system can be completely separate from the main engine lubricating system or can be fed through the main engine lubricating system, depending on the design. Mostly, the turbocharger with outwards bearing position has its own sump and a lubricating pump attached to the turbocharger shaft, along with a provision to store oil within the casing. The engineer on duty must ensure the oil inside the casing is always above the mark in the gauge glass. For a lubricating system which is fed from the main engine lubrication, it is essential to have a separate filter for turbocharger lubrication, which is generally a duplex filter. The outlet of the lube oil from turbocharger have a side glass to make sure the flow is continuous. A lube oil supply must be maintained when the engine is stopped, as natural drought through the turbocharger will cause the rotor to turn. Hence, the bearing must be lubricated. The load-dependent lubrication of the cylinders is performed by a separate cylinder lubrication system. The cylinder oil is kept in a storage tank from where it is transferred to the cylinder daily oil tank for engine usage. It is fed to the engine cylinders via quills fitted in the liner. Cylinder lubrication is required in order to lubricate the piston rings, which reduces the friction between the rings and liner, and to provide a seal between the rings and liner. It also reduces corrosive wear by neutralizing the acidity of the products of combustion. The cylinder lubrication applies boundary lubrication method to reduce heat and friction between piston and liner. The alkalinity of the cylinder lubricating oil should match the sulfur content of the fuel supplied to the engine. If the engine is to be run on low sulfur fuel oil as a requirement of IMO 2020, advice must be sought from the cylinder oil supplier and the engine builder as to the most suitable cylinder oil to use. It is located under the engine in the double bottom and is surrounded by cofferdam. A sounding pipe to know the level of lube oil in the sump is provided, along with a sounding pipe for cofferdam to know if there are any leakages. The main engine lube oil sump consists of a level gauge, sounding pipe, air vent pipe, heating steam coil, manholes, suction pipe, and valves for lube oil pump and lube oil purifier. It is assumed that the engine is stopped but is being prepared for starting. Check the level of oil in the main engine sump tank and replenish if necessary. Ensure that the low temperature center cooling system is operating and that fresh water is circulating through the main lube oil cooler. Ensure all pressure gauges and instrumentation valves are open and that the instruments are reading correctly. Ensure that steam heating is applied to the main lube oil sump tank if the temperature of lube oil is low. Set the line and make sure all right valves are open. Select one main lube oil pump as the master pump and the other as the standby pump. Please do note that the main lube oil pumps have large motors and are generally fitted for auto transformer starting. After a start, the auto transformer must be allowed to cool down for at least 10 to 20 minutes before another start is attempted. Keep the lube oil system circulating and allow the temperature of the system to gradually increase to normal operating temperature. Check the outlet flows of the individual unit. Check that temperature are similar and all pressure gauges are reading correctly. When lubricating system temperatures and pressures are stable, the engine may be started. If you have any questions or suggestions, please drop your comments below and we will get back to you at the earliest. If you like this video, please subscribe to Marine Insight channel and press the bell icon to get notified when we post such amazing videos. Please like, comment and share this video and do not forget to subscribe to our channel.